So I'm going to switch gears a little bit. This is more talking about OTN. I was going to ask how many people know what OTN is, but I'm really afraid that no one would say anything and then you would go to sleep because you're just wanting me to finish as fast as possible to get to lunch. So I'm not going to ask that question. Instead, I'm just going to move on and say OTN is more of a physical layer protocol than what you've been talking about here. This is obviously you've been talking about layer 7 and above. But it's something that you're going to hear more and more about. And it is something that we like to talk about a lot because you're going to see it and we think you should know about it. So quickly, let me go through, and I guess I can control this, right? Who is MRV? For those of you who don't know, we're one of the sponsors here. We're glad to do that. I am going to put these back on because otherwise I can't see what you're doing out there. Well, probably I shouldn't. I don't really want to see your faces that closely. We've been around for about 25 years. Our headquarters are in Chatsworth, California. Our major design groups are in Chatsworth, by the way, is right outside of Los Angeles. And if you know where Chatsworth is, you're lucky. I had no idea where Chatsworth was when I got there, but it's just outside Los Angeles. We have another group that's just outside of Boston, and we have another group that's in Israel. And we have 3 people here today. If you look in the back, the attractive one and the other one, that's Andre and Ed, and they'll be around asking questions. And I was told to make sure that you put in a business card because they don't want to take this back with them. Security doesn't like it when you bring stuff in and out of the country. So we're giving away an iPad. If you put your business card in the thing downstairs, you can take that through security and customs, and we don't have to. So please do that. What MRV does, we build packet systems, we build optical systems, we build lots of different things. Primarily, what I'm going to talk about today is more of our optical systems. WDM, lots of bandwidth. A lot of our customers have been represented on slides you've seen earlier today, so this is something that we're very familiar with. This is a community that we're very involved in. But I'll try not to spend too much time talking about commercial things. I really want to talk about this other stuff. What is OTN? So OTN, it's really interesting. You can see it backwards up there, which is kind of confusing. OTN was designed as sort of the next generation of TDM. If you're familiar with Sonnet SDH, which is kind of a bad word these days. You don't want to talk about those acronyms. They didn't work very well for data guys. OTN was the community saying there was some good stuff in there. Let's see if we can adapt it to use in more modern networks, because there's some things that SDH and Sonnet did very well that we're losing when we go to all packet networks, and sometimes you might want to have them back. So it's really designed to optimize, for example, the use of fiber, especially between locations, where you may have multiple protocols running. You may have different things like fiber channel. You may have some old TDM. You may have Ethernet running between locations. You may have digital video. All these things that are running over networks these days. OTN is designed as a way of bringing those together and very, very efficiently using what's typically a scarce resource, which is fiber. This drives down the cost of the network. It lets you have a common infrastructure, and there's some really nice applications for this, all of them coming around the idea that there's some new things you can do based on what looks like old technology, but taking the best out of it and not using everything else. Pointing this way. The OTU standard, I put this in there mainly just to let you know that we do know how to read standards. I don't expect you to actually read them. The ITUT likes to write standards. They like to put lots of fancy diagrams, pictures like this that show all the different layers of stacks and how the headers and everything go in. You really don't have to worry about that. Someone else has already figured that out for you. The point is, this is a standard. It was put together by the ITUT, which, for those of you who are not familiar with the ITUT, it's part of the UN. I don't know why. But that just tells you that a lot of people were involved. This is definitely not something coming out of the U.S. This is something that communications providers across the world. What's really interesting about the ITUT is you may have lots of telecommunication providers, say in the U.S., they get one vote as the U.S. You may have one telecommunication provider in Pitcairn Island, although I doubt you even have one there, they get one vote too. But they typically get smart people together and they come up with some very nice standards. So these standards do exist. If you'd like to go online and read them, G709. You may have heard of G709 primarily for the overhead it gives you for forward error correction to go longer distances. But it does a lot of other stuff too. So the acronyms you're going to hear, the things that people will talk about, there's a lot of things, like I mentioned in here. They got lots of different stuff on here. You don't need to know all that. The ones that you will care about, the ones that will come up in conversation casually on the train are, what's an OTU, what's an ODU, and you'll never hear anything else. There are other stuff in there you'll never hear. An OTU essentially means if it is a wavelength being transmitted between 2 points, it's an OTU. If it's the stuff inside, which you can stack lots of them up together, that's an ODU. You'll never have to hear anything else. So that's all you have to know, OTU and ODU. And there's a huge hierarchy. This is actually a Sienna slide from a Sienna poster, which most people have in their lab. It's really cool because it goes through all the different ones. And it's mainly intended to really show you how smart show other people how smart you are, because you understand what this diagram means. Most people don't. And most people will never care. These are all the different things that you can take and put into OTN and come out with these standards on the other side. The reality is you'll only ever know 3 of them. Maybe 4, but really 3 of them. ODU 0 was designed around gigabit Ethernet. ODU 2, they're applauding for me already, I hadn't even finished. ODU 2 is designed around 10 gig Ethernet in particular, and ODU 4, which is designed around 100 gig. There's an ODU 3 in there for 40, but most people don't use it. There are some other things in there as well, and we're talking about one going higher up into the 400 gig range, but those really are the only 3 you need to know about. You may need to know about ODU Flex, which is a way of stacking up ODU zeros to make an arbitrarily sized container. But generally, you don't need to know about all this other stuff. Just know those 3, and you can sound smart in conversations and at parties. It's a recursive structure, though. There's nothing that says you have to have this many of those to go into this many of these, and everything works together. You can take a bunch of ODU zeros, say 8 of them, into an ODU 2. Remember, these are giggies. That's a 10 gig, so 8 of them go into it. But you can also say, now I've got this thing here, which is 100 gig. It doesn't have to just be a bunch of ODU 2s. It can be an ODU Flex. It can be a bunch of ODU zeros. I can plug a bunch of other things in here. You can mix and match to fill up the bandwidth. And this is one of the things that didn't work very well in Sonnet SDH, and they did a much better job of with OTN. If you have a network that is almost entirely one big block of Ethernet, you can allocate a one big block of Ethernet in there and just have a little bit of other stuff on the side. In fact, most of you, if you are using 10 gigabit Ethernet over any distance at all, are probably already doing this. It's probably actually an OTU2 with forward error correction on it, so you can go over longer distances. Unless it's just within the data center or within the internet exchange, you're already doing it, you just don't realize it. There's a lot of other things they can do too, though. So this is the question that comes up. Why not just use, and then you name a technology, MPLS-TP or the old Ethernet or MPLS? Why would we want OTU? Why would we want OTN? What does it give us that these other things don't give? Well, first of all, it's low latency. One of the best things about TDM was if you were a bank or you were somebody offering a low latency service to a bank, you could say, I'm going to give you a circuit that everything that comes in one side never gets routed. It comes to a certain specific time slot. That one will always be the same time slot all the way through. It comes out the other end as fast as light can do it. It's really, really low latency. As soon as you do any sort of switching of any kind where you have to do some protocol analysis in there, where you have to actually look at headers, it slows things down. TDM is great for this. Low latency is the #1 reason that they do it. Scalability is nice too. If you're building a really large network and you've decided that you want to go with PBB, well, at some point you run out of space and you've got to start segmenting those apart. There's a lot of other protocols that run into these same kind of issues where you run out of space, you've got to segment them apart. With OTN, the intention was that as long as you've got a time slot, you've got space to put more services on it. Incredibly scalable, just like the old TDM stuff was. Interoperable. And in fact, we have a very large carrier in the US, I can say their name because they've talked to me, named Level 3, that was built to be an entirely IP network. When they came out, there was this big thing. We're going to be the first all IP network. It's IP over glass. Their entire network is actually based on OTN. And the reason they do it is for interoperability. They can go out and buy from a variety of different vendors and make sure that even over long distances, they always interconnect. And they can go and talk to other carriers and do protocols across long distances, and they always interconnect by saying it's always going to be OTN framing. That way we don't have to worry about it. So interoperability is a nice one. But this is the one everyone uses, the built-in forward error correction. It allows you to go over longer distances. Most of you are probably already doing it. If you go over any distance at all, you've got forward error correction built into the transceivers already. If you look at a transceiver and it says it's going over an extra long distance, it's probably using forward error correction. If it's using forward error correction, it's doing it with OTN. So this is where most people have seen this before. And customer and service separation is one that's just come up recently where if you've been in the industry for a long time and you ever worked with a financial institution, when WDM first came out, multiple wavelengths on the same fiber, there are financial institutions that said, I will not let you do that because I'm afraid someone's going to be able to see my traffic. They've gotten over that. But now they're saying, we want to have logical separation of our services, and OTN allows you to do that. It's For example, we have a large customer who's doing this with cell backhaul, cell tower information coming in. A single tower can have multiple different clients on it. Each one of them wants to make sure they get their own guaranteed bandwidth through the network, no oversubscription problems, no worries about anybody else is doing. I want a pipe from end to end. This allows you to do that. Some of the other benefits, very nice bandwidth utilization by packing all these things together. Essentially anything that you run below 100 gig can be packed in there. Performance monitoring. You can actually look at the performance of your network and tell people how it's working. This is the old Sonnet SDH stuff. The difference is it's not over-engineered. If you ever worked with Sonnet, I've been in this industry for a long time, so I started out working in Sonnet. There was some stuff built into the Sonnet overhead that was listed as for later use. It was never used. That was wasted bits. There was something in the overhead called order wire. Anybody never used order wire? The intention of order wire was if you've got two technicians working in different locations and they need to communicate with each other and they don't have any other way to do it, they can plug in a headset and talk over the order wire channel. We now have cell phones. We don't need this anywhere. So there's a lot of stuff built in the Sonnet overhead that we never used. All that's gone out of this. And then there's lots of nice optical tools. SDN, you'll hear lots of stuff about SDN. Everybody wants to talk about programmable. You can do that at this layer as well. In fact, most people who talk about optical SDN or transport SDN consider OTN to be part of that. So here's the point. Should you actually care? This was a survey that was done in 2013. In 2013, they went out to a bunch of different service providers and said, do you think OTN needs to be in the same switching platform as all my Ethernet, MPLS, and everything else? And they said, no, right now, most of them, that's not really. But by 2016, 89% of them said OTN is going to be part of our switching structure. And that switches out there that they're going to be deployed are going to have OTN in them. So there are a lot of people out there who are very involved in technology who believe OTN is going to have to be part of the network design going forward. So even if it doesn't apply to you today, there's a very good chance at some point in the future you're going to encounter it. So how does it work? This is an idea of how it works. Generally, you have low-speed interfaces that do adaptation. They bring in Ethernet, they bring in Sonnet SDH, they bring in fiber channel, they bring in digital video, they bring in CPRI, they bring in anything you can come up with. They adapt it up to whatever this OTN is, and then you have a traditional cross-connect at ODU 0 or below. Cross-connect things together, match them up, mix them, and stick them out. Any signal essentially from 100 meg to 4.25 up to 10 gig can be adapted in there. So if you have a network where you're running some storage, so you have some fiber channel, you have some old legacy stuff on there, you're running some video for clients, all that needs to be combined together. Typically, you'd have to put them on separate fibers or on separate wavelengths. This is a way of putting them all together, switching them around nicely, and sending them off. The nice thing about having a cross-connect in there now means you can drop them and add them and move them around very flexibly. Pluggable optics for most things, lots of redundancy, lots of other things that you could do with traditional equipment you can now do with this stuff as well. Generally, what it looks like is you have the low stuff coming in, it's switched locally on the card, and then goes into what is a common fabric card. So if you talk about somebody saying, well, I want Ethernet and I want OTN on the same switch, it's now a common card. That one card that did your Ethernet switching or your MPLS label switching, whatever, can now do both. So if you look at, and I'll show you some pictures of the equipment that we've actually built that does this, the switch fabric can do both things. So it's not like you're out buying extra hardware. This is all a very good thing for you. This is what the hardware looks like. This is a couple of things we've done. I won't spend a whole lot of time on pictures of our stuff. You can always go to our website and get more. But typically you have things like an OTN mux spawner, which is 100 gig out and 1010s or some 40s coming in. This is a switch that brings in anything from 100 gig up to 2.5 gig and comes out as 10 gig. This is just a 100 gig transponder, brings in 100 gig, puts it in an OTN wrapper and sends it out so you can go over longer distances. Those are all parts of this platform, which is our optical platform. And then when you talk about switching, this is a switching platform. This is one that can actually do both. It can do OTN switching and packet switching, and these cards in the middle can do both. It's just a matter of what the adaptation card looks like. Is it an Ethernet card or is it an OTN card? You can fully flexibly switch across them, and you can actually switch between one and the other. You can come in Ethernet, combine them together, and come out OTN. So there's a lot of really nice things. And it can do things, it does it like this way, essentially. These are 100 gig ports. If you don't have 100 gig ports, you're going to have them soon. It's nice how small they're getting. Our first 100 gig ports were this, actually our first 100 gig ports were this big. Now they're about that big, and then now next year they'll be that big, and then they'll be smaller. You can put lots of different clients on. You can adapt different things into it. It's amazing the flexibility of this protocol. And because I have a lot of time, and I do talk kind of fast, This is one of the application. Essentially what it is you can bring in lots of different things from lots of different places, and the idea is to have a common infrastructure in the core that's interoperable, that's scalable, that's low latency, and lets you build networks that carry just about anything. This is the one that everyone wants to talk about. This is the application when you go to trade shows and everybody says, well, what's the first thing you're going to do with OTN? Well, I'm going to build a packet optical system, and I'm going to do it for router bypass. Everyone wants to talk about router bypass. And there's a good reason for that. Routers are expensive. Router ports cost a lot of money. And if you have a network that has a bunch of different things coming together at one point, and there's a router sitting there, you want to use as few of those ports as possible. So the first thing you do is you say, if I've got anything carries 100 gig E, I keep it as a wavelength. I never drop it into a router. I take it from this network over to that network. It never drops out. But if I have a bunch of other stuff from enterprise customers and switches and other things coming through, and I can consolidate those together some way, to make a wavelength, either through OTN or Ethernet, do the same thing. Again, never touching your router. If you can have things that are services that are OTN, if you have video and all those other kind of things, you never want to touch those into the router either. So again, consolidate them together, switch them at the OTN, never drop them in the router. If you have MPLS, if you have carrier Ethernet, if you have those kind of services, those aren't routed services. It'd be nice if you had a switch in there that could do both. Remember, same switch does both things. Switch it through the packet, and only consolidate things and hand off stuff that requires routing at the very bottom. I was on a panel recently with a bunch of people from a bunch of different companies talking about how great this application was, and everybody on the panel except for the guy from Cisco thought this was a great idea. He seemed to have a problem with it. I don't know why. There's a lot more detail in here. I know I only had 30 minutes, and I do tend to talk relatively quickly. But the main point to make here is that oh wait, actually there's a slide that's missing. Where did it go? That's right. I had a slide in here that was questions, was discussion questions. It got dropped out somehow. But discussion questions were things like, if I'm a small provider and I've only got Ethernet and everything inside my network is only Ethernet, do I need OTN? The answer is probably no. For now, that's probably all you need, but you're probably using it without realizing it because it's got forward error correction and there's overhead. But if I'm building a larger network and I'm starting to interoperate with other people and starting to touch other people, then it starts to be a bigger issue. And I gave myself some extra time to remember these questions, and I don't remember all of them were because they aren't on the slide. So feel free to raise hands if you have some, otherwise I'm going to keep asking myself questions that I know answers to. The other question was, is this only something that service providers could care about? And the reality is what we discovered is it's not something that just, obviously the service providers are the ones who wanted it first. So if you deal with a large carrier, they're very much in the OTN ballpark. They want to do that. That's what they want to do. They think they see it being familiar, being something that they can offer, do services on, something they consolidate a bunch of things on. But we also have some customers and people who are deploying it who are not service providers specifically for those applications. And the one cell tower one is the one that was really interesting. This is a carrier, or this is essentially a backhaul company that talked to a bunch of different cell towers, and they collected all the traffic and they would hand them off to the different providers. They just own towers. And they had to do it with OTN because the customer said, I want guaranteed bandwidth. And I want it low latency, and I want all the other things that come with cell backhaul. And so we put this nice proposal to them and said, look, you can do this all with OTN. It's all ODU zeros. They're all gig E's. You get 100 gig at the other side. It's an OTU 4. You can hand them off all at once. This is a great idea. They said, that's terrific. And they went to their providers and they talked to them and they came back and they said, we don't know what an OTU 4 is. We need Ethernet. Oops. Well, the great thing about these packet optical systems and about OTN in general is you can break everything apart, take it back down into OTN. You can actually put a VPN per ODU 0 and hand it all off as a gigabit as Ethernet, and that was a great solution for them. They were able to have all the benefits of it, but for the end customer, it looked like an Ethernet network end to end with essentially fiber in between. They hadn't to know anything about the network. It was completely abstracted as a cloud, which is a great thing about OTN and about SDN in general, is you'll eventually be able to see this just as a pool of resources that are pipes that aren't the wavelength level, the sub-wavelength level, that you'll be able to reroute around and program as much as you want to. Yeah. You're the only one raising your hand, so go ahead. Oh, microphone, sorry. For the folks playing at home, we have a contestant in the audience.
Yes. So what about vendor interoperability on this?
Vendor interoperability at the protocol, where it's just attaching them, works almost perfectly now. Remember, if you remember the old Sonnet SDH days, there were always some pieces of the protocol that never quite worked the way they were supposed to. The nice thing about OTN is that part will work. If you connect a forward error correction, a FEC OTN 10 gig on one side, and the other side it'll work. Now the stuff underneath, the stuff inside may not line up. But at the higher level, interoperability is working just fine because it's a relatively simple protocol.
What about the forward error correction on 100 gig?
Forward error correction to 100 gig, well, okay, 100 gig, nothing is interoperable right now, essentially. Up to a point. An SR or an LR, a short one, will work fine. But when you start talking about coherent and going over longer distances, FEC is pretty much only used on coherent, single wavelength systems. Almost none of those are interoperable. Our solution to that is to only use pluggable optics. So that if you want to buy our solution on one end and use somebody else's on the other end, you buy the optics from the same company, the FEC is built into it. $100 gig is really cool. If you
Any
haven't
other
used 100
questions?
gig
There
yet,
you go.
it's really nice.
Do you transport dynamic synchronous transfer mode?
Dynamic synchronous transfer mode. I'd have to check. I'm not familiar with that. Is that an OTN protocol? Or are you talking about within the Ethernet?
It's Ethernet Live.
I haven't heard it put specifically that way. There's timing protocol transfer. The nice thing about OTN in general is you can actually put a synchronous signal inside of it and use it to transfer timing. But I'd have to check what exactly that protocol is.
Last question. Anyone?
What's for lunch? By the way, 20 euros, you get to the top of the pack for this thing.
Okay, well, thank you very much, Scott, for that presentation.